Let's look at a way to find the equation for f inverse. And let's say the original function f of x is 2x plus 1. So here's the idea. Here's the property for inverse functions. Let's draw a picture of what this f function looks like. So f takes x as your input and sends it in. And the first thing it does is multiplies x by 2. So it sends it through the multiplication by 2 machine. And out of that, of course, comes 2x. And then it takes 2x, the result of that, and adds 1. So it sends it to the plus 1 machine. And finally, you get 2x plus 1 as your output. Okay? So this is your f function. So let's see what this means about f inverse. F inverse undoes f in the reverse direction. It takes it back apart. So x goes in, and it's going to go through this machine backwards and do the opposite. So the first thing that's going to happen to your input on f inverse is instead of adding 1, you're going to subtract 1. So you're going to go through the minus 1 machine, and out of that, of course, you now have x minus 1. Then it's going to keep going, and it's going to go through a similar machine to this. Instead of multiplication by 2, it's going to go through the divide by 2 machine. And out of that, you're going to get x minus 1 divided by 2. So what that means is the equation for f inverse is this right here, x minus 1 over 2. It does the exact reverse of what f does. Okay? So this is a really neat way to look at it. Gives you a good understanding of inverse functions and their relationship with the original function. But sometimes this isn't practical. Sometimes you run into really complex functions. So let me show you another way to do this with a more complex function. So in this function, notice how x is in two different places. That really makes it difficult to draw that machine diagram that we did over here. You should try to pause and play with that for a minute and see what difficulties you run into. But what we're going to do is look at another more algebraic, more technical way of doing this, finding the equation for f inverse. So just a few notes here to get us started. So we're going to use y to represent the original function. So I'll just rewrite it as y equals 3x minus 1 over x plus 2. Then if you remember, in an inverse function, what was x in the original is now y, and what was y is now x. So I'm going to swap those. So I'm going to replace y with x and x with y. Now, remember the original y represented a function. It was the original function. When you swap these, this new y represents the inverse function. So our goal is to solve for this new y, and the issue is that there's two of them. So we've got to see the algebra of how to do this. So the first part's not difficult. It's probably pretty natural. Multiply both sides by y plus 2 to cancel this denominator. So we end up with this canceling. We have 3y minus 1. And on the left side, distribute your x to get your y out of the parentheses. We still have y in two places, okay? So what we're going to do is, if we want to solve for y, we better have all the y's on the same side of the equation. So I'm going to get all my y's on the right side, let's say, okay? So I'll keep my 3y over here, and I'll subtract my xy. I better move this 1 over because I want to focus on the y's. So I'll move it over here, which leaves me 2x plus 1. Now this is the tricky part here, so you might make a big note, highlight this, write yourself a little comment next to this step. How do you solve for y? Well, let's factor y out on the right side. And that leaves 3 minus x, and then over here we have 2x plus 1. Now I can solve for y very simply by dividing both sides by 3 minus x. And so y equals this fraction, and that is, remember this y is f inverse of x, that is the inverse function, equals this, and now we have the equation for f inverse. Okay? So this is a good way of doing this. This seems to work more frequently than the little drawing method we used at the beginning to represent the function. So give that a shot.